Okay, in this video we're going to focus on direct lighting, and we're going to have a little sub focus on the standard lights in XSI. So this won't take too long. We'll go over this really quick, but it's something that you have to understand before we get into the heavy duty production scenes. Okay, first thing I'm going to do is I hate this brown color, so I'm just going to go to the shader real quick, and I'm going to change it to a neutral gray, which looks much nicer. Okay, now if we go ahead and create a render region here, we'll notice our lighting doesn't look too great. We don't have any shadows. We have sort of this weird gray ambient lighting in our scene, which pretty much destroys the look of our scene and whatnot, and you really can't render well like this. Well, this is the default lighting in a brand new exercise scene. I haven't touched the lighting in the scene that you opened up here. It has all the default lighting. So whenever you create a new scene in XSI, you're going to end up with something like this. A lot of grays, no shadows, and one sort of mysterious light that comes from the distance over in that direction somewhere. Okay, so what's causing this default lighting, and how do we change it? Well, it's pretty simple. If we go ahead and hit 8 on the keyboard to open up an Explorer window, we'll notice that there's this hidden light. And I know it's hidden because it has this little gray H right here on its icon. That means that it's hidden from the viewport. It's not hidden from the render, but it is hidden from the viewport. So Mental Ray can see it and render it, but you can't see it in the viewport. If I hit H on the keyboard, I'll unhide the light. And you'll notice that the light is in fact in the scene. If I grab it and I just move it anywhere, and it doesn't matter where you move it to, just go ahead and grab it and move it. You notice that we do have this light, and it's an infinite light. And every brand new scene in XSI by default has one light created automatically, or else you wouldn't be able to see anything and you would just get a black render. And that automatic light is this light here, which is just called light. Okay, this is the default XSI light. Also by default, any brand new scene has a small amount of ambience. What's ambience? Well, it's sort of this fake attempt to create indirect illumination. And we'll be talking about indirect illumination further down in this tutorial. For now, we'll just go ahead and just take my word for it. If we go over here to the render toolbar, and under the modify menu, we'll see this button called ambience. Now if we go ahead and click on that, you notice that we have this ambience lighting parameter, and it's only one parameter, basically color. By default, it's set to a value of 0.2, 0.2, 0.2 in the R, G, and B, or red, green, and blue channels. If we go ahead and create a render region tool here, render region window, and we increase the amount of ambience, and if you move the slider and only one moves at a time, that's because you didn't use the control key. If you hold down control when you move any one of these sliders, you can move them all simultaneously. If you don't hold down the control key, you'll move them all one by one. And what I want to do is hold down control to move them all together. If we come over here, we can see that we can actually increase the amount of this global lighting, or this ambient lighting that's right here. See on the back side, the shadowy sides of the sphere. We can see that we can darken it, or we can brighten it up. So this tries to create indirect illumination. However, this is a very fake and cheap method of creating indirect illumination because it's not physically accurate and it's not realistic at all. So the best thing to do is to just turn ambient lighting off, especially if you're going for a photorealistic render. And it's best to just create your own custom light rig and your own custom indirect illumination yourself, either using final gathering, irradiance particles, global illumination, or just using a custom light rig like they do in a lot of feature films and productions. So I'll close that. So now we have no ambient lighting. Any areas that have no lighting, which in this case is the back side of the sphere, the back side of this cube over here, or this swiggly thing, are just going to look pure black. And that's exactly what I want. Okay. Now in XSI we have a lot of different standard lights. Let me just select this default light, and I'm just going to hit delete on the keyboard to get rid of it, and now everything's black. This is exactly why XSI creates a default light for you automatically, because if not, this is what you would get, and you'd probably think, uh-oh, what's going on here? I think the software might be broken, which of course is not the case. XSI works perfectly fine. So what are the default lights, or any type of standard lights we can place in our scene? Well, if we go up to the primitive menu, then we go down to this light menu, we get all these different lights. We get an infinite light, light box, neon, point, and a spotlight. In this video we'll talk about the standard lights, because we have standard lights and we have area lights in XSI with Mental Ray. And there's a pretty key difference between the two, and I'll show you what it is in a moment. The first standard light that we have is an infinite light. So let's create an infinite light. And you notice that the icon looks like this. And this icon looks just like the default light that we just deleted. That's because it is. The default light is an infinite light. An infinite light pretty much mimics the way that sunlight works or parallel light rays work. Basically, the light just shoots in one direction and everything in that direction gets lit up by the light. And it all gets fired in one single direction, which you can actually grab and rotate and move anywhere you want. So if I aim this thing kind of down at an angle coming out from an imaginary sky, you notice that the light reflects that here in the render region. We can change different options here for the infinite light, such as the light's intensity. If I create a render region, I can increase the intensity or I can lower it. I can also change the color of the light, so I can change it pretty much to anything that I want. Okay. I can also turn on the shadows, and shadows are going to make this look more realistic, and I have an Umbra parameter here as well. We'll talk more about shadows in a moment. Right now I just want to show you the different types of standard lights and XSI. We can also switch the light type here, the standard light, from an infinite to a point or a spot. But the way that we're going to do it is a little bit more of the longer way. We're just going to take the light, delete it, then we're going to go back to the primitive menu, back to the light menu, and I'm going to tear this menu off by clicking on this scissors icon here with the little hash lines. And I'll just tear that off. That way I have the menu here available to me whenever I need it. The next thing I'm going to do is pull up a point light, and a point light can be found right down here. This is another type of standard light in XSI. And a point light works kind of like a light bulb. It shoots light in all directions, 360 degrees around it. So if I create a render region, you can see that there's the point lights here in the middle. Okay, this is very good for creating something that is a source of light, such as a light bulb, or maybe the sun and outer space, something like that. Okay, so it's a very useful little light there that can be used for many different things, and it has the same soft light parameters here as the infinite light. For example, you can change the intensity, you can change the color, so on and so forth. Okay, so let's close that and let's delete that point light. And let's create ourselves a different type of standard light, which is a spotlight. Spotlight is a little bit different. Basically, the way it works is kind of like an infinite light, and you can direct it more like a flashlight. But it's not exactly like an infinite light. What this does is create a spotlight effect like you would see in a movie theater or a play, or it can work just like a flashlight actually. And what it comes with when you create it is an interest point, which is this little null here. And wherever I move this null, you can notice that the spotlight tries to face that direction. So it'll always follow and look at that interest point, which is defined by this little icon right there. Then you notice there's another icon that looks just like it here where the spotlight is, and that's the actual root of the light. If I move that around, it moves everything with it, the interest and the spotlight itself. That's because this object here, the spotlight itself and the interest point, are parented to this root. If I take the spotlight, I can move the spotlight independently, but you notice everywhere I move it, it's always going to face that interest point that's located right here. So if we take the spotlight, you notice it has its own unique icon, which looks like a spotlight used in, say, in a stage or in a movie theater, things like that. And if I hit enter on the keyboard, I can open up its PPG, and you notice that the options look very similar to the options from the point light and the infinite light. You can change the intensity, you can change the color, you can add shadows, so on and so forth. So let's go ahead and aim this spotlight here toward our sphere. We can do that easily by moving the interest point right to the sphere like that. And now the spotlight's going to be looking right at that sphere. And you can see the spotlight effect that's created. So it creates this nice spotlight effect. So what we're going to do now is grab that spotlight, hit enter to open up its PPG, and have a look at some of these options. We can turn on shadows, for example. Then we can turn the Umbra all the way down. So now we can see some nice dark shadows in our scene. We can also change a few different things. For example, light attenuation, also known as light decay, can actually mimic the way that lights work in real life. You notice that it goes completely black. What this option does, light attenuation, it basically tells the light to decay. It uses the actual behavior that light follows in real life. In real life, light doesn't just stay constant forever. It actually decays and becomes weaker the longer distance it has to cover. It's just like if you take a flashlight outside at night and you flash it towards the side of a building. If you're very close to the building, the actual light that hits the wall is going to be pretty bright. The farther away you walk away from the building, the more faint and weaker the light ray becomes. This is the way that light behaves in real life, and by turning this option on, light attenuation, you can actually have lights in XSI behave the same way. But you notice that when I did that, the scene turned black. Well, it's not broken. What that means is that we don't have enough intensity. What we need to do is increase the intensity by a large amount. In this case, I'll increase it to 100, and now we can see. Areas that are closer to the spotlight, which is right here in this area, are very bright. As soon as the light goes very far away, in this case out here, the light becomes more faint and weaker until eventually it drops off and there's no more light. This kind of light behavior, this light decay or light attenuation, is extremely important and vital when you're creating a photorealistic scene. And even if you're not creating a photorealistic scene, I still recommend that you use it. It'll just increase the quality of the lighting in your scene. Okay, let's also look at shadows. When we turned on shadows here, we automatically turned on what's called ray trace shadows. If we go over here to shadow map, we can turn this on and use shadow maps. So what's the difference between a ray trace shadow and a shadow map? Well, shadow maps can render out faster than ray trace shadows, but require more memory on your system. Ray trace shadows work the opposite. You don't need a lot of memory to render them, but you need more processing power. So ray trace shadows can render a bit slower than shadow maps, depending of course on your scene. Ray trace shadows though are more physically accurate than shadow maps. And ray trace shadows work best when working with objects like glass and other transparent objects, as you can't create transparent shadows with ray trace shadows. With shadow maps, you can't do that. You also can't create good shadows with shadow maps when working with something that's alpha mapped, which could be a problem in a scene depending on what the project is that you're working on. So we'll turn shadow maps on and we can change the resolution. The resolution is going to affect the quality directly. If we go ahead and perform a render region here, and actually let me get real close so we can see this. So I'll get behind this sphere, right about there. So you can see now we're using shadow maps to create the shadows for the sphere. If I reduce the shadow map to say something like 256, you notice that the shadow map now has less quality. You see these jagged edges and a lot of aliasing, which is not good. This is not happening because of the quality settings of the render region. In fact, it's happening because the resolution of our shadow map is so low. It's only 256. So if we increase it to say 2048 or 2K, you'll notice now that the shadow map becomes very high quality. It takes just a little bit longer to render, not much, but the shadow comes out much nicer quality. We can also change the bias here, which will affect the way that the shadow... Actually, no. Let me leave the bias alone. Edit that part out of the video, the part with the bias. Edit that out of the video. I'm going to start again in 3, 2, 1. Okay, so we could take the softness here and we can actually add softness to the shadow. So as we increase the softness, and let's really increase that by a lot more. Let's increase it by about 0.1. Okay, hang on. We're going to edit that out of the video. Edit that out of the video. And we're going to start again in 3, 2, 1. Oh no, sorry. Not going to start again now. Okay, now we're going to start again. Okay, starting again in 3, 2, 1. If we come down here we can take this softness parameter, and if we increase the softness, we'll actually make the shadow less harsh. As you can see here, the shadow is pretty harsh. Just has this line where it's shadow and light, which is something that you may or may not want. If you want to get rid of that, increase the softness here. So right now it's set to 0.002, which is a very, very small value. We'll change that to 0.01, which is a much larger value than before. If we render that out, if you notice, it was pretty subtle, but the edges of the shadow got softer. Let's go ahead and increase that to 0.5 and render it again. You'll notice now the shadows are extremely soft, actually too soft. So I'll reduce it to 0.1. It's a very sensitive parameter. You can see I'm using extremely small numbers like 0.1, and even with such a small number, the effect is very, very strong. In this case, you don't want to make the effect too strong because then your shadows are not going to look very good. So you can see 0.075 works a lot better and makes these nicer, softer shadows. And the reason it's coming out all grainy, of course, is because my anti-aliasing is down. So if I increase my anti-aliasing to increase the quality of the render, it'll help to alleviate some of that artifacting. But you don't want to increase the softness too much because you get to a point where even though you increase your anti-aliasing, you're still going to have plenty of artifacting, and then you're going to be forced to blow out your anti-aliasing and slow your render time down dramatically, which is not what you want to do. So I'll reduce that to 0.05, and that looks a lot better. Okay, we can also increase the samples, and if I decrease the samples to say something like 5, and I render again, you notice we have more graininess and the quality of the shadows just got worse. But the render's faster. If I increase the samples to say 50 and I render again, you can see it now, the shadow looks a lot better. And I actually didn't suffer a big hit in rendering time. It actually rendered at about the same amount of time, just the quality was improved, which is a really, really good thing. Okay. Then we have volumic shadow maps. Volumic shadow maps are great when you're using shadow maps with something like hair or fur. If we go over here to area light, we can turn on area light parameters, but we'll talk about area lights in the next video. For this one, I just wanted to show you the difference between shadow maps, which is everything that we just did here. And if we turn that off, we're automatically using ray trace shadows, which look like this. Okay. So that's going to cover, that's a quick discussion here on the standard lights. Just one more thing that I'd like to show you here is if I take the spotlight, I can actually activate a spotlight manipulator. And you can do that easily by hitting B on the keyboard. So if I hit the letter B, B for Bravo, you notice that we get this manipulator that pops up. And it allows us to do different things. For example, if I left click on this yellow area here, I can change the actual cone angle of the light. That was an error. Edit that out of the video. Going to start again in 3, 2, 1. So if I click and drag on this yellow area, I can change the spread of the light. Let me hit enter to open up the light's PPG so you can see this yourself. If I have the PPG open, keep your eye on the spread angle parameter down here that says 3.184. As soon as I click on this and I start moving it, you can see the parameters updating in real time. That's because I can use this manipulator to change parameters like the spread angle interactively in the viewport, which you may like to do a lot better than coming in here and changing a parameter numerically in the PPG. So it's really up to you. And over here, this pink line or this pink ring here at the end, we can take it and we can drag it, and that's changing the end fall off parameter down here for the light attenuation. I can also control the start fall off. If I zoom in here and select this cyan colored ring, I can change the start fall off. And if I click on the actual white outline here, these white lines that go from the spotlight and connect to this pink ring, I can actually click and drag that to change the cone angle of the light. So you can see up here the cone angle parameter up here is changing whenever I drag that. So you can change the spotlight parameters interactively, which is a pretty neat tool, and I really do recommend that you take advantage of it in your workflow when working on your productions. Okay, so that's going to do it for this video. It's gone long enough. We're going to go ahead and end this video here, and in the next one we're going to cover area lights in XSI.